Hello, this is Team USA made up of Austin Kitts, Noah Russ, Ben House, and Samuel Kashani. We had the Hovercraft project for Freshman Engineer Design Day 2014 at NC State University, and we're in Section 15 of E101 taught by Miss Leaf Starling.
This is the research component of our project. The first hovercraft was built by British engineer Sir Christopher Cockerell in 1955 and was named the SRN-1. The vehicle made its maiden voyage across the English Channel in 1957. The science behind the hovercraft. A hovercraft generates lift by creating a pocket of air beneath it. The air is trapped by annular walling that forces the air back towards the center of the craft. This walling is parabolic in shape, and the craft has no bottom, so the air is completely trapped.
The engineering design process was important in the building of our hovercraft. We first asked what the problems of building the craft would be. Next, we brainstormed some various building ideas. We then planned by drawing possible designs for our craft. After this, we finally began to build our craft. After we had a working craft, we began to improve upon our own design.
For the hovercraft problem, we had to build a hovercraft that could travel 40 feet down a linear track. We could use RC parts, but we could not use a commercially developed hovercraft or hovercraft kit, and we could not spend over $40 to build our hovercraft. After researching, we began to brainstorm ideas for our hovercraft. We had many ideas that we had listed in our meetings, such as using rocket engines as propulsion or an inflating inner tube as our skirt. But we narrowed down our ideas to what we used in our hovercraft and were able to create an initial design.
The initial plan consisted of two fans, one for downward thrust to lift the craft, and the other facing backwards for thrust to move the craft. It would be steered by two rudders controlled remotely and powered by two D-cell batteries on board. The final plan consisted of only one motor to provide thrust and lift for the craft. It was powered by two 9-volt batteries and consisted of an RC component and was constructed out of a bag and a meat tray.
During the create portion of the design cycle, we began putting pieces together to build our hovercraft. Our first working design had a few problems, namely, it did not like to go in a straight line, and it was too heavy. We solved the problem of staying straight by using a note card as a stationary rudder to direct the airflow. We reduced the weight of our craft by replacing 6 AA batteries with 2 9-volt batteries and reducing the number of motors from 2 to 1.
Our team had a great day at Fed. We arrived at the McKimmon Center and set up for our project. After a few announcements, the competition began. Our hovercraft had the fastest time on the track and was named the Freshman Engineering Design Day first place winners.
The largest challenges we faced in our Fed project include a broken RC unit and a balance between weight and power. In our first design, we planned to use an RC unit from various devices. However, it soon malfunctioned and we had to reevaluate our design. It was also difficult to decide whether we should use a large battery with more power or a light battery with less.
Some things that we could add to our design to make it a more successful craft is to construct a way to steer the craft by changing the direction of the airflow of the draft of the fan. Also, we could figure out a better way to power the craft rather than two 9-volt batteries that would die quickly.
For future advice, our team would advise next year's freshman engineering students not to procrastinate. They also should choose Fed projects which they will enjoy. Finally, future students should not stress about Fed too much. It is a fun, memorable day. Here are the sources that were used for our project. Thank you for watching.
created using Powtoon.